In this explanation, we will review all the steps of the cement industry. Cement mill system. Kiln process and operation. Part 1. Cement production. The stages of cement industry are divided into 3 stages. The first stage. Raw material preparation. This stage begins quarry to kiln feed, including storage, blending, grinding of raw material and fuel, homo-silo, dosing and dedusting. The second stage. Clinker production. It consists of preheater, calciner, kiln, burner, and clinker cooler. The third stage. Cement production. It consists of clinker storage to cement dispatch, including grinding, separating, transport, storage silo and packing. Clinker burning technology. General. In this figure, the path of the raw material, fuel, and gases, in the cement industry stages is shown. A. The raw material. The material is feed, from the highest point of the preheater. As the raw material moves inside the preheating tower, it is mixed with hot gases. The raw material falls to the entrance to the rotary kiln. A cooler receives the material after it leaves the rotary kiln. The material is stored inside silos after it has been removed from the cooler. B. Fuel. The raw material is heated at 2 points. 1. The main burner, from the outlet of the rotary kiln. 2. Calciner in preheating tower. C. Gas and fresh air. For the clinker cooling process, fresh air is pumped into the cooler, through a set of cooler fans. Gases are removed from 3 outlets. 1. Degassing of gases and clinker dust, through the cooler filter fan. 2. Through the ID fan, all gases are withdrawn by ID fan. This gases passes through the rotary kiln and tertiary air duct, passing by preheater. 3. Through the bypass fan. In some cement factories, it is not available. The raw mill is fed with hot air, and the rest is expelled through the chimney. Process of the kiln plant in general. 1. Preheater. 2. Calciner and burner. 3. Rotary kiln and main burner. 4. Clinker cooler. General informations about 1. Interlocks and process flow diagrams. 2. Control loops. 3. Sub-control systems. Preheater. We described previously the path of the raw material, from the time it enters the preheater until it exits the silo. This path is shown in this figure. Also, this figure shows the path of gases inside the preheater. The figure shows counterflow heat exchanging system between cold raw meal and hot kiln gas, multi-stage system. 1. Heating up of the raw meal. 2. Cooling down of the exhaust gas. 3. Vaporization of water. 4. Dehydration of clay. 5. Partial decarbonation of the raw meal. Calciner. The primary function of the calciner is to decarbonate the raw meal, 90 to 93%. The energy required for this purpose comes mainly from the calciner firing system, from the exhaust gas of the rotary kiln and tertiary air from the clinker cooler. Rotary kiln. The preheated and mainly decarbonated raw meal, from the lower preheater stages is conveyed via the kiln inlet into the rotary kiln. The raw meal is completely decarbonated, on its way through the kiln, is brought to clinkering temperature and is clinkered. In the clinkering zone, the clinker mineral formation is concluded. The energy required for clinker formation is supplied via the main burner to the rotary kiln. The pyroprocessed material passes a cooling zone at the end of the rotary kiln, which is longer or shorter, depending on the position of the burner. The clinker then falls at a temperature of approximate 1200 to 1400 degrees C into the cooler. What are the different zones in a burning kiln? Zones of rotary kilns with calciners. Cement kilns with preheater towers have 4 major refractory zones: the calcining zone, the transition zone, sintering zone, and the cooling zone. Sintering zone. Formation of the clinker minerals: tricalcium silicate, Ca3, SiO5, C3S, alite; dicalcium silicate, Ca2, SiO4, C2S, belite; tricalcium aluminate, Ca3, Al2O5, C3A, aluminate; calcium aluminate ferrite, Ca4, Al2, Fe2O10, C4AF, ferrite. Residence time, or retention time, is the time it takes for material to move from the feed end of the system to the discharge end of the system. Kiln retention time formula: T equals 11.2 time L over R time D time S, where L equals kiln length, R equals kiln RPM, D equals kiln effective diameter, S equals kiln slope. Noticeable: there are many other equations for calculating the retention time. Clinker cooler. What is clinker cooler? The clinker cooler, also known as grate cooler or cement cooler, it is a necessary equipment of cement clinker production. The clinker cooler is mainly used to cool and transport the cement clinker. The main components of the cooler: Grate 1, Grate 2, cooling air, main drive. The cooler can be divided into 2 zones. 1. Recuperation zone. 2. Cooling zone. Coolant processes can be summarized as follows. Secondary air, nearly temperature fluctuates from 900 to 1100 degrees Celsius. Tertiary air, nearly temperature fluctuates from 800 to 1000 degrees Celsius. Cooler exhaust air to filter, nearly temperature fluctuates from 100 to 120 degrees Celsius. Clinker cooler. Static grate or grate cooler. The essential characteristic of a grate cooler is a layer of clinker spread on a more or less horizontal perforated grate, through which cold air is blown. The grate is made of steel, and the cold air keeps it sufficiently cool to avoid melting or burning. One of the most important features of static grate: homogeneous clinker distribution to avoid red rivers, and good wear resistance. Interlocks, process flow diagrams. 1. Machine protection, PMI, or fundamental interlocks. Protection of the machine itself, for example, bearing temperature, oil temperature, gearbox. 2. Sequence interlocks. All drives of machines are mutually interlocked. It means if one machine fails, for example, overload, all drives in the sequence preceding the failed machine are shut down automatically. 3. Process interlocks. Interlocks in relation to the process and safety, for example, gas analyses kiln, preheater, coal mill analyses, CO, cement mill outlet temperature. Main plant interlock. An interlock diagram of a rotary kiln, in the cement industry, can be seen in this diagram. PFDs means, process function diagrams. Process function diagrams of a rotary kiln, in the cement industry, can be seen extract in this diagram. Control loops. In this slides, we will explain all the control operations that occur in the rotary kiln. Main control loops of a rotary kiln plant. 1. P. Pressure. 2. T. Temperature. 3. V. Volume flow. 4. D. Depth, thickness, height. Control loops. Slide 2, we follow the explanation the control operations that occur in the rotary kiln. Main control loops of a rotary kiln plant. 1. Pressure after dough pole, ID fan. To be kept by the speed of the EP fan, or fan damper respectively. For compound operation, the pressure before EP fan is used. Control loops. Slide 3, we follow the explanation the control operations that occur in the rotary kiln. Main control loops of a rotary kiln plant. 2. Kiln hood pressure. To be kept constant by the speed of the cooler exhaust gas fan, or fan damper respectively. Control loops. Slide 3, we follow the explanation the control operations that occur in the rotary kiln. Main control loops of a rotary kiln plant. 3. Exhaust gas temperature. To be kept constant by the amount of the injected water into the cooling tower. Important for direct operation. Control loops. Slide 4, we follow the explanation the control operations that occur in the rotary kiln. Main control loops of a rotary kiln plant. 4. Pressure aeration chamber 1 equals depth of the clinker bed. To be kept constant by frequency of the transport tracks. Control loops. Slide 5, we follow the explanation the control operations that occur in the rotary kiln. Main control loops of a rotary kiln plant. 5. Cooling airflow rate. To be kept constant by cooling fan speed or fan dampers respectively. Clinker cooler. Cooler control loops. This figure shows the stages of controlling the clinker cooler. Sub-control systems. Main control system. From company ABB. Shock blowers. Local control panel. Main burner and calc inner burners. Sub-control system. Clinker cooler. Process control system Siemens, S7. Steps operation of the plant. 1. Commissioning. 2. Drying of the refractories. Preheater, tertiary air duct, cooler. 3. Heating up the kiln plant. 4. Start-up sequence in general. 5. Start of the kiln line, and kiln feed. 6. Increased performance. 7. Normal operation. 8. Normal shutdown of the plant. 9. Troubleshooting. Each of these steps will be explained in detail. Commissioning. Preparation works and pre-checks. 1. Check all drive motors for correct direction of rotation. 2. Check the electrical control systems and interlocks. 3. Check all measuring devices and indicators for proper functioning, signal check. 4. Check the sequences of the individual groups. 5. Calibration, are all dosing devices calibrated? 6. Test run of all individual drives. Remark. Checklist of each individual machine and part, see operating manual. Drying of the refractories. Normally in 2 steps. 1. Separate drying of the preheater, about 4 days. By using 1 or more auxiliary burners. 2. Final drying with the main burner. When the plant is heated up, about 2 days. Measures before drying. 1. The pendulum flaps in the meal chutes have to be fixed in open position. 2. The steam openings in the preheater, on the top of the cyclones, must be open. 3. Fresh air flaps, in the exhaust gas duct, must be open. 4. Inspection flaps and doors, of the upper cyclones, stage 5, must be open. 5. Natural convection of the gas is used. Dopole, ID fans not in operation. Example. Monitoring at the drying procedure. 1. Temperatures have to be measured, all 4 hours. 2. Increase of temperatures, maximum 10 degrees C, per hour. 3. Stepwise increasing of the fuel quantity. 4. Drying is finished when reaching 100 degrees C. In the upper cyclone stage, and kept for a minimum of 24 hours. Attention! The instructions of the supplier, refractories, must be observed. Example of measurement of the temperatures. In this figure: A. Brick lining. B. Inner side of cyclone. C. Insulation. D. Measuring point. Approximate schedule of drying. Day 1. Low temperatures, oil quantities, 150 to 300 liter per hour. Day 2 and 3. Increased temperatures, oil quantities, 250 to 600 liter per hour. Day 4. Slightly more increased temperatures, 400 to 900 liter per hour. Targets of the temperatures, example only. See the following table showing the temperature values in cyclones during 4 days. Attention! The instructions of the supplier, refractories, must be observed. Drying of the tertiary air duct and cooler. Example only. Backdraft of the hot gases by the cooler exhaust air fan. Maximum temperature in the tertiary air duct: 288 degrees C. Maximum shell temperature of the tertiary air duct: 98 degrees C. Attention! The instructions of the supplier, refractories, must be observed. Heating up of the kiln plant. We will mention the steps of heating rotary kiln. Start of 1. EP filter and dopole, ID fan. 2. Primary air fans. 3. First 4 cooler fans. 4. Fresh air flaps, in open position. 5. Start gas analyzer. 6. Ignition of the main burner. 7. Oil quantities, 500 to 800 liter per hour. 8. Assured, Compact flame is needed. Tilting of the rotary kiln during heating up. This table shows the timings. Tilting of the rotary kiln during heating up. After 3 hours. Tilting of the rotary kiln, 180 degree. From 4 till 12 hour. Each 2 hours, tilting of the rotary kiln, 120 degree. From 13 till 26 hour. Each hour, tilting of the rotary kiln, 120 degree. From 27 till 34 hour. Each 40 minutes, tilting of the rotary kiln, 120 degree. From 35 till 40 hour. Each 20 minutes, tilting of the rotary kiln, 120 degree. From 41 till 46 hour. Each 10 minutes, tilting of the rotary kiln, 120 degree. From 47 till 48 hour. Continuously with the auxiliary drive. Example of heating up with oil. In this shape, illustrates the relationship between oil quantity and period in hours. Adjust the pressure conditions, suction. Combustion air volume at minimum. No CO. The heat remains in the clinkering zone. A short and compact flame. Example of heating up. In this diagram, illustrates the relationship between temperature and time per hours. In 3 parameters. 1. After dough pole, ID fan. 2. At stage 3. 3. At kiln inlet. Attention! The instructions of the supplier, refractories, must be observed. Thank you for showing interest. With family greetings, everything about the cement industry. I hope for your support by subscribing to the YouTube channel.